It can be easy to forget that molecules are three-dimensional objects. Valence shell electron pair repulsion theory, or VSEPR, uses our understanding of the ways that electrons repel each other to help us predict the three-dimensional shapes of molecules, also called molecular geometries. We'll demonstrate how to use VSEPR to analyze a molecule by working through the process with ammonia. Through this, we'll also take a look at several different ways to represent a molecule. The first step is to draw the Lewis structure. Ammonia has a formula of NH3. If I consult a periodic table, I can see that each hydrogen should have 1 valence electron and nitrogen should have 5, for a total of 8 valence electrons. I'll start by drawing the central atom, which I know is nitrogen since hydrogen is never the central atom, and placing the other atoms surrounding it. I'll then use 2 electrons between each outer atom and the central atom to form bonds. Since hydrogen can't form any more bonds, that leaves 2 more valence electrons to be a lone pair on the central atom. The steric number for this molecule is 4, since the central atom has 1 lone pair plus 3 bonds. According to the molecular geometries table, ammonia, with a steric number of 4 and 1 lone pair, should have a molecular geometry of trigonal pyramidal. I can also conclude that the nitrogen is sp3 hybridized because of that steric number of 4. To represent the trigonal pyramidal geometry, I'll draw a perspective drawing using the wedge and hashed wedge, also called wedge and dash notation. I'll start by drawing 3 groups in the plane, since any 3 points are on a plane. And for the remaining hydrogens, I'll put 1 on a wedge and 1 on a hashed wedge to represent that this one is going back into the plane and this one is rising up towards us. I can compare my perspective drawing to a 3-dimensional model of a molecule, either a physical molecule or a computer model. On MoleView, I can type the name of a molecule into the search field, or I can manually draw the molecule. Physical model kits may have a guide that shows which colors should be used for which elements. Many complex geometries are possible. Another thing you're asked to do in this experiment is to count 90-degree electron interactions. Some interactions are between bonding pairs of electrons, and some are between bonding pairs and lone pairs. To count these interactions, make sure you understand the perspective drawings. Recall that on this molecule, the atom attached to a wedge is coming out of the plane, and the atom on the hashed wedge is going back into the plane. The angle between these 2 electron groups is 120 degrees, and the angle here is 90 degrees. We're mostly interested in the 90-degree interactions, since those are more energetically unfavorable. This experiment doesn't involve actual chemicals, but model kits will be available for you to use in the lab.